Okay, you are once again welcome back to this wonderful Arduino tutorial. Today on tutorial 15. On our last tutorial we discussed about the circuit analysis and the analog write command, and after the analog write command we discussed about circuit analysis, the Ohm's law, and we built a circuit. I hope you still have your circuit, and that is this circuit. We built this circuit where we have two resistors in series to 5 volts. So 470 end of the resistor is at the 5 volts, and the 100 ohms resistor is at the ground, and both of them meet at a junction, which is the common center tapping connection being connected. So we did this circuit, and I did something here. Okay, I've removed it. Okay, now so in today's we are going to discuss about analog read command. The analog read command. What is analog read command? What do we understand by analog read command? Why do we need analog read command? We write to a pin, we give a pin voltage, but a pin can also receive a voltage. In the case of sensors, when you are talking about sensors that gives out values, might not give out a steady values, might give us a values in between. How can we get Arduino to know that these values are coming in? So we use analog port in analog port. We use analog ports, that is the pulse width modulation port, to do what? To write. Now we are going to read. To write means to give a port a voltage, to give it a voltage. Now to read means for the port to accept a voltage. So let's understand this so that it can sink into our mind and our brain. So when you are writing to a port to receive a voltage. So the port will, and when you are writing to a port to give out a voltage, either pulse or steady voltage, either float voltage or steady voltage. So that is analog word, write. The port is giving out. And when it comes to pulse width modulation, analog voltages, we have dedicated pins, just like I told you. The pin from pin number 3, 5, 6, 9, 10, 11, these are pins that you can use for pulse width modulation. These are pins that you can use to write analog voltages. And when it comes to analog read voltages, these are the pins you are going to use. You are going to use the analog in pin, which is from A0 to A5. That's the 6 pins of the analog in. Now this is it. Now we are going to read the analog voltages from our circuit analysis, where we have the 470 ohms resistor, which is the R1 resistor, and the 100 ohms resistor. Still go to your sketches, where you sketch something like this, and okay, sketch something like this. That is where I'm reading from. Okay, so where we have our voltages, we are going to read now. We're going to read the V1, which is the voltage across the. We're going to read the V2, which is the voltage across the center tap voltage. This is what we are going to read. The V2 voltage is what we are going to read with Arduino, to see how Arduino reads these voltages with our what? With our serial monitor. So we are going to set up our serial monitor where you can see what the Arduino is reading, and we are going to write a program for that. We are going to write a program for that. So we are going to go to analog read now, not analog write, analog read voltage. We are going to read the voltage from the pin of this resistor. We are going to read. Okay, now so let's go straight to the point, and by the time we guess, well, let's go straight to the point to code. By the time we start coding, I will also be mentioning a lot of things. And okay, and in the last tutorial on circuit analysis, we got the V1 has to be 4.12 volts, and our V2 has to be 0.877 volts. 0.877 volts. That is the voltage across the resistor in between here. Okay, this is the voltage we're talking about here. Okay, am I getting it? Let me come very close so that you can see this place. Voltage across here, this place, this one. So, which is 0.8 volts. Okay, so that is V2 0.87 volts, or 0.9 volts approximately. So that is it. So we are going to now in the Arduino. Let me bring the camera very close so that you can see. There's my Arduino. Okay, so now this is my Arduino. This is how I hooked it up in our last tutorial. You can see. So okay, very simple. You have from 5 volts to the plus, from ground to the negative, and down the resistors are in series. You can see the resistors in series. So that is it. So that is how I hook it up. Now I'm going to, from Arduino, I'm going to the analog. You see where it's written A0 to A5. So I'm going to use A3. I'm going to use A5, sorry, because I want to use A5. You can use A3, the analog input. That is where I'm going to read. I'm going to start from there and put in between the resistors here. In between the resistors here. So and put in between the resistors here. So that is it. So that is what I'm going to do now. So that is it. So I'm going to put here in between the resistors. You can see between the resistors. Now I'm going to insert it in the A5, because I choose to use A5. Insert it in A5. Okay, so now we are going to code. Now this is where the story will begin. This is the start of the drill, and let me do something so that I will put myself and okay. Okay, so now let's see how we can be able to okay, very good. I like the shot. Okay, now let's see how we can be able to let's go to our IDE so that we can be able to code and write this program so that the Arduino, the IDE, the Arduino can now read the voltages. Then before that, we also try to read the voltages with multimeter so that you can see how what we actually meant by using Arduino to read the voltage. Now, just like I told you, what we got from is 0.87 volts, that is 0.9 volts approximately from V2, which is the 100 ohms resistor, and that is the voltage across this place, and voltage across this place. So that's 0.9 volts, that's voltage across here. That's what we got from here. So you can see from the multimeter, I can position the multimeter for you, then we can read the voltages so that you can see the voltages yourself. You can see it, 0.9 volts. Okay, so that is it. And we got here, and what we got from this one, from the V1 is what? From the V1 we got what? 4.1 volts, and the voltage across, the potential difference across the two resistors is what? 5 volts. Okay, so let me put minus to minus, plus to plus. Okay, we got 5 volts. It's not okay, 5 volts complete. So we got 5 volts. So that is it. Now we are going to read. We are now going to make the Arduino to read these voltages as we are reading it with what? With a voltmeter. So we are going to use our serial monitor. So when time comes up, I will call up my serial monitor. So from here you can call up your serial monitor. From here, this point, you can call up your serial monitor. This point, call up your serial monitor. If I'm using this one, from here I can call up my serial monitor. Okay, so now bare minimum, just like I told you, this is where you used to write your distance. So let's begin to write our programs. So that for the sake of time, so that we can be very fast, I've just written a little code inside this place. Then so we are going to, I'm going to interpret what I've written so that you can follow along with me, not just putting figures and the writing values, and at the end of the day you won't understand what I'm saying. So now, first of all, we have to use our not integers, so that's our int, that is our variables. Remember I showed you how we use our variables in our previous tutorials. We use variables. Now we are going to use variables here. So first int, and there is some place I will put float. I will not I will not use float for now, for the sake of for you to understand. I will just use int. When the time comes for float, I will tell you which one I deleted and put float so that you understand. So let's go now and see. Now read pin is A5. That is our A5. Our read pin, where we are reading from. Which pin are we reading from? Which pin is reading? It's making the reading. Which pin is going to be the probe of the multimeter of the Arduino? That is the A5, pin A5. That is A5. You can see, just like I said, A5. Pin what? Pin A5. That is where I plug it. Pin A5. Look at it here. Pin A5. That is where I plug the probe of the multimeter. Look at it. It's making the reading. Remember, the ground is ground all through. The ground is ground. That is 0 volt all through. So pin A5 is what? Is the read pin. So that is it. Which is read pin is equals to what? A5. Int. That's another variable, so another integer. V2, which is the voltage across the resistor. This is voltage V2. We are reading V2. This voltage across this resistor, voltage here. So the V2, just like, okay, so you see what I'm saying now. V2 voltage across resistors, voltage across this resistor. Let me come close. Okay, very good. Okay, so V2 voltage across this resistor is what? It is 0 volts. Why we use 0 volts, I will explain to you. Just put 0 volts for the sake of programming so that we can have a value there. I will tell you why we use 0 volt in that place. Okay, now long delay, int long D, so that when you print, it's wait and print, so that you won't be doing I'm printing, you will not be able to read what you are printing. So just like you see in the, you saw a number and the number came to stay, and you see how the is printing in line, it print, it will be reading it, it will be printing it, it will be reading it, it will be printing it, you know, it will be reading and be printing, reading and be printing, reading and be printing. You just be going like that. You will not have, if you don't put a delay, you see it just a you can't be able to read. So a delay, just like we have done in our previous tutorials about how we use delay for us to actually see. Delay allow us to actually see what we are doing. Okay, so that is it. Now let's go to and see. So we have the long D delay on okay. So you see, you have here, we have the long D. Okay, this, we don't have to make use of this. Let me increase this. So this will be up here, and this, which one? Benjamin. Okay, let's keep it this way. Okay, so long D, you have to add a delay. Just like I told you, you know the importance of delay, so for you to be able to see. Okay, now P mode. When we come to P mode, normal P mode, and your voice setup, where you set up your parameters, or you set up your pin. So your P mode, the read pin, which is A5, pin 5, on analog read pin, it is A5, is read pin, that is equals to A5, and it's an what? It's an input pin. It's input pin, it selects the voltage, input pin, where the voltage enters, sorry, not select, where you feed in the voltage from the board, from the circuit board, there's the circuit board. So that is it. That's the read pin, which is A5. This is what senses the voltage. When you interface the sensor with Arduino, just like when you interface the sensor with Arduino, it will be the pin that the sensor is being hooked up with. So that is it. So one thing about Arduino, one thing I want you to understand about Arduino is that let us not just see this board as where you just punch in program and they start manifesting, start giving you result. Let's see it as a board. Let's see that a board, just like ordinary normal electronics board, we see it as a switching board, and they have this mentality that Arduino is the same ICs you use. You know, when you use timer 555, when you use the flip-flops and the rest of them, and when you use where are the different switches, the pulse width modulation IC SG3024 we use for inverter that time, and the see it's a combination of different, you know, ICs you used jam packed together. It's a combination of different switches. Flip-flop is inside, pulse width modulation, which is SG35, the normal, the inverter pulse width modulation IC, and you see it as a timer 555. You see it as just see it that way. So don't see it as one kind big stuff like that you put in program, you know, say no, it's just a combination of millions of switches jam packed together, and the pins are being routed out for you to, you know, feed in your informations. And the same way you use your op amps in your photocell experiments and your thermistor experiments. You use op amp for thermistor sensor. Thermistor is sending temperatures, and the clicking relay is the same way you feed in information from that place. You use an analog, you know, but this one, it reads a voltage from the sensor, so you have to arrange the sensor in such a way that it's going to be producing a voltage. Finish. That is it, a varying voltage. And Arduino takes it and interprets it and give out the result. That is just it. So, and in the output side, you have to set it in such a way that it's also going to read a voltage, which is what on or off, or pulse width modulation, or varying voltage, either 0 or 1, or in between, or float voltage, or either is 0, which is 0 volts, or is 1, which is 5 volts. So you see it that way. You see this Arduino that way. So that is it. So in your sensor, when you start interfacing sensor, you find out that you make your sensor in such a way that as the Arduino is reading the voltage from the sensor, if you are using the humidity sensor or the temperature sensor, the thermistor is doing such a way, or the photo cell is doing such a way that as the light is coming to the photo cell, there will be producing, the sensor will be causing a variation in voltage. So the Arduino to read the variation in voltage and to interpret and give out the results. So that is just it. So let's see it that way. And the earlier we understand it that way, the better for us, and the better you understand how this board works. It's a very simple board. It's a very simple board. If you have your understanding, that you can work with. Everything has been already cooked, already made for you. So it's not longer the days that you use the Atmel. Normal you use soldering iron to to solder, to add other features, to add other buffer, other stuffs like that, buffer transistors, and jump pack everything. You understand what I'm saying? The old school type of doing using TopWin programmer or other programmers to do stuff like that. And this time around, you use the board straight. You don't need additional programmer. Everything you program with the board has already comes with its programming stuff like that, hardware. So it interfaces with the system, and that's all. Each board comes with its own. So you don't need a special programmer that you bring out the IC and you program. Now we are on the pin mode. We have pin mode. We have the read pin, which is pin 5. Let me go so that you want to see what I'm doing. So you have the pin mode, which is pin 5. Pin 5. Where is it? Pin mode. Read pin, which is A5. A5, not pin 5. Analog input pin A5. Where you can interface your sensor, your humidity sensor, and all these places is where the analog in pins is where you put your sensor. All manner of sensors you have. This is what takes it. It's a 6 pin from A0 to A5. So these are A5. So that is it. And which is A5 is what? It's the read pin, which is what? Input device. Remember to put your semicolon and put your column semicolon. Then serial.begin. How did this thing get into this place? This serial.begin, this program, this code. Okay, I will now explain serial.begin. Just like I told you, the serial monitor. And in this place, it's a course on its own, it's a topic on its own. But for us just to jump it, just mention it, just to set up your serial monitor. You have different types of baud rates. This is 6900, 6900. There are other baud rates, good baud rates that you can also input in this place. When we come to this as a topic on its own, we can be able to treat it. But for the sake of this program to run, just put it that way. Serial.begin, you are setting up your serial monitor, your baud rate, so it has to be on the voice setup. So you have to be on the voice setup for you to set it up. So now we are done with what? The voice setup. Now in the loop, where the program is running, the looping, play looping music, loop, prom, finishes, it start again, finishes, it start again, loop, void setup, you set, loop, it plays, continuous process, just like pasting, continuous process, from. You cannot just do one, your motor will be checking, continuous process, the vehicle will be moving. So continuous process of pressing. So that is it, looping, prom, continuous. Program will continue to run. So this is it. It's a very simple. I'm trying to use different scenarios to explain what I'm saying. Okay, so let's go back to the program again, and so that is it. And you have what? Here is void loop. In void loop, we have the V2. Let's forget about the V2. We have the analog read. Yeah, it's reading from read pin. Okay, it's reading from read pin, which is what? A5. What is it reading? The read pin, what is it reading? Is it reading my head? Is it reading a textbook? is reading V2, 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 V2. So V2 is equals to analog read, which is what? Read pin, which is read pin, A5 reading. So this A5 read pin is reading what? V2. So V2 is equals to what? Analog read, which is read pin. So it's reading V2. And our int here in our variables here, V2 is equals to what? 0, 0, 0, 0. Okay, now let's go. Serial print. Serial dot print in line, which is print INLN, print LN, that is print in line V2. So when it reads, it has to print it out. It has to print it out. As it's reading it, it has to be printing it out. That is it. As your voltmeter is reading a voltage, it's reading a voltage with the probe. It has to print it out for you to see. It has to print it out. It has read it for his own consumption. Then for me to see what the voltmeter has read, so it has to print it out. So that is it. So it's different things, it's the same process. So let's go again and see it. So this is what? Read pin. Serial print in line, and we have serial dot print in line. It has to print it. Printing what? V2. V2 is printing V2. What is reading from V2? V2. And remember our V2 here int is what? V2 is supposed to what? 0. Okay, now we have to put a delay, because if we don't put a delay, you see brrr, zrrr. So there must be a delay. There must be what? A delay in the system. Without the delay, you will not be able to see. So remember, all our programs we have been adding delay. Remember our Morse code. Remember our Morse code, how we added a delay in our Morse code for us to be able to differentiate date, da, date, stop, long delay, date, da, date, long delay. So that is it for you to see the other date, and for you to see the da. Remember that program? So the same way. So when it prints, you see. It prints again, you see. It prints again, you see. If you don't want to put a delay, you just put you will not see. So that is it for you to see. Put a delay program, and in that delay program we have long D. Remember our delay, long D, that is int long D equals to what? 1000 seconds. No, not 1000 seconds, 1000 milliseconds. I did not understand seconds in milliseconds. So 1000 what? Milliseconds. So that is it. Now we are going to print this program. We are going to upload this program, download it to the Arduino board, and we'll open our serial monitor. So let's see. That will bring us to another phase of this tutorial. Okay, let's go ahead and see. And this is it here. You can see it. You can see very close. Very close. Okay. Now I'll open my serial monitor, and okay, let's download and see if the program is correct. Okay. Ooh. Good. Okay. Now let's open my serial monitor from here. You open your serial monitor from here. From here, look at where I'm pointing my cursor. So I open my serial monitor. Let's see. It has started. Okay, you can see the values. Okay, I'm seeing 182. You see, it's reading it's reading, it's going. I can clear output again. Let's start again. Okay, start again. Okay, you can see, let's clear again. Let's start again. Okay, prom. That is the delay. That is the delay, the 1 second delay. Like your electronics watch, your digital watch. That is the 1 second delay. So if we put if we come here to do it, maybe do it 3000, to become 3 seconds delay, so that you will be able to understand this. Let's do 3000. Let's upload and see. Okay, Let's clear and see. Okay, you see it? You see it? 3 seconds. After 3 seconds, it gives you another value. You read another one. So this is 181, 181, 181. And we know fully well, you can see it now, you can see it, you can see it yourself, you can see it yourself. So we know fully well 181 volts, this board cannot produce 181 volts. Arduino works with what? 0 or 5 volts in and out. In and out, 0 or 5 volts in and out. You cannot work with 181 volts. So where comes 181 volts? Is there an inverter inside that produces, that steps up the voltage? Is there an inverter inside that steps up the voltage? So where comes 181 volts as our V2? So that is it. That brings us to another one. Remember, in our analog read, analog write, we have a scale of voltage scale that Arduino understands. A scale. Remember the 255. Remember the 255. If it is 0, it is 0. If it is 5, it is what? 255, a scale of 255, which is what? 2 raised to the power of 8. 8 bits. Now, in the analog read, we have what is called the 10-bit system, where you have what? 1023. That should be 1024, which is 10-bit system, because start from 0 is 10 what? 1023. So in analog read, you have it at what? 1023. That is 1023. That is 10-bit. Understand? So that is 2 raised to the power of 10. So it's a scale that Arduino understands. Like I told you, you say, why should they do it that way? Why shouldn't they leave it at that 5 volts and let's stop confusing? I'm not the one that produce Arduino. I'm not the one that write the programs. The way the people that design the program design it, that's where we are flowing them. So say you just have that mentality and have that understanding, you will flow. So it's the same thing. If I tell you that 0 is 0 and 5 volts is what? 1023. A scale of 1023. So you do your cross multiplication. Very simple. You do your what? Your cross multiplication. It's a very simple. It's not a differentiation. It's not a calculus stuff. Thing. It's not a circuit theory. It's not a circuit theory stuff. It's a very simple plus or minus, division and addition. The equations are very simple. The Ohm's laws are very simple. Electrical is a basic electrical equation and a basic mathematical equation. So you do your cross multiplication. If I have 0, it's equals to what? It's equals to what? It's equals to 0. And I have 5 volts. It's equals to what? 1023. So if I have 3 volts will be equals to X. So I do cross multiplication. Then I get my X on the scale, on the Arduino scale. So that is it. I will get my scale. So that is it. So now I have a scale. Then I have to get the voltage. So in the same way. So now let's see it. Let's see it. So I have a scale of 180, 183. Let's clear the output again and start afresh. Let's clear and start afresh again. And let's see. Okay, 180 now. Okay, we'll have 180, 180, 180. Okay. Okay. Or 180 is somehow steady. We have 180. Okay. Before we go and do the little cross multiplication calculation, let's remove the probe and see what happens as we remove the probe. And let's see what happens as we remove the probe. So this, I will remove the probe from here. From here. Let's watch and see. Oh. Let's put it in 0. Ground pin. Let's actually see. Okay. Let's reset, clear output and see. Okay. You see 1. Okay. Let's put again and see. It's supposed to be 0. Why am I getting why am I getting 14? And it's supposed to have 0. It's supposed to have 0 because it's in grounds. It's supposed to have 0. Okay, let me look for another ground again and insert it. Okay, I have 0. I have 0. Okay, I have 0. Okay, good. Okay, so I have 0. When you insert it in a ground, that is 0 volts. It's reading it as 0 volts. Okay, now let's insert it where we have 5 volts. Let's see what is going to read it. 1022. 1022. 1023. 1023. Okay, so let's go back again and insert it in across the in between the resistor, the center tap where you have to say here. So let's see again, just to buttress my point. Okay, you have 187. Okay, let's clear again and start afresh. Okay, you have 186. I have 186. I have 187. Okay, let's allow it to print so that we can take our average. Okay, 187, 186, 187 is constant now, 187 is constant. Okay, so that is it. Very simple. Okay, now so we take 187. So we do 5 cross multiplication. So let's get our value. So let's go back and see and do the small mathematics here so that we can be able to get our values. And I've done it before for the sake of this tutorial so that you will understand what I'm doing. So where did this guy get all these values? Is it forming values himself? Where is he getting all these values? He's coming here to bombard my head with a lot of figures here. Okay, so let's do it this way. Let me push the system and the Arduino one side. Okay, and then let me bring my papers. I've done it here. You can see where I solved it. So let me see. And okay. Okay, so very simple. So now, just like I told you, you have a okay, let me use red pen so that you can see very clearly. Okay, so just like I told you, if 0 is equals to 0 and 5 is equals to 1023. 1023 is a scale of 1023, which is equals to 2 raised to the power of 10, which is 1024 anyway. That's all right. Okay, now we have your binary. So now you have the V2, our V2, which is what is reading at 179. Now I have 179. So if 5 is equals to 1023 and V2 is equals to what? V2 is equals to what? 179. So what is V? So it's a very simple cross multiplication. You do like this. Very simple. This goes to this. This multiplied by this. This multiplied by this. Very simple cross multiplication. Okay, so you have V2 into times 1023 is equals to 5 times what? 179. V2 will be what? This goes here, your normal calculation. V2 will be equals to 5 times 179 over 1023. V2 will be equals to what? 5 over is equals to 5 over 1023. Understand? multiply by 179. Very simple. Whichever one you do first, either you do 5 times 179 or times over this one multiply by this one, it gives you V2. So let's do it with my calculation, with my calculator, sorry. So very simple. So now I have 5 over 1023, 5 divided by 1023, 1023, 23. Okay, I got 0.0048 something multiply by 179 times 179, 17979. Okay, I have 0.8748. So I have V2 is equals to what? 0.8748. Go. So it is approximately 0.9 volts V. So now you can see the ray actual world voltage, this rays voltage we normally see in our physical world. So this is the ray voltage we normally see in our physical world. So we have this 0.89 voltage. So that is it. And when we read it with our voltmeter, it's the same voltage that we are going to get across V2. So now let's read with our voltmeter and see. Let's read with our voltmeter and see the voltage. And see the voltage. Let's read it with our voltmeter and see. Okay, now boom, I have my voltmeter, my fluke. Try as much as you can to use fluke. Get any fluke. The cheaper ones, must not buy the expensive ones. There are expensive ones, the ones with mega, combination of mega and rest of them, but there are cheaper ones. These ones are cheap, these ones are not the expensive ones. So it's just for you to, it's a multimeter and a pump meter. As an electrical person, I'm an HVAC person, I prefer this because it's a multi-dimensional stuff for me. It cuts across this thing. Like there are other ones that's strictly for a lot of instrument guys use it, and the electronic guys can also use that one because of my nature of the job I do. I choose to use this one. Okay, so now let's go straight to the point, and so that we can be able to see, to measure, to read the voltage. Now I can see, yeah, this is 0. Now we are going to read across. So the V2, which is what the Arduino actually is measuring. So what we got on our calculation is what? We got 0.87 volts. So now we measure that a voltage across V2, which is the 100 ohms resistor. So that is it. This is the V2. So we scale it and see. You see it's 0.9. So that is it. This is it. The probe here. 0.8, 0.9. So exactly what we got from our calculation. So very simple. So you can now see how we use the scale value to get the actual voltage. How we use the scale value to get the actual voltage, using the scale value to get the actual voltage of the Arduino. Okay, now how can we do it in such a way that this Arduino will read the actual value, the physical value, the real world voltage? How can we do it that way so that we can also see 0.8 volts in the serial monitor? So that is going to take our program to the next level. So this calculation, we are going to do a little bit calculation inside the IDE. Going to do a little bit maths. A very simple mathematics. We are going to do it. We are going to introduce integer of what? Float, because 0.87 volts is not a what? It's not an integer. It's not a whole number. It's not a whole number. It's not an integer. Let me put it that way. It's a floating number. It's a number in between 1 and what? 0. It's a number in between 1 and 0. So it's a floating number. So we are going to introduce another variable called what? Float. And then we'll do a little bit calculation inside the IDE. So let's go and see how we can do that. Okay, now let's see. Leaving the hardware like that, and then let's close our serial monitor. And okay, let's close the serial monitor, and that will bring up this for you, where you will put int read voltage. Okay, so now let's go and see. We'll change. This is there's another a variable we are going to introduce, which is the read voltage. So which is equal to, just like we said, V2 is what? Is the read voltage, and it's what? V2 is what? The read voltage. So we are going to introduce the read voltage, which is analog read, which is read voltage. So now let's see. Let's do this mathematics. This and this is equals to this, but this is equals to this based on this mathematics. This is equals to this. Read voltage is equals to V2, and this V2 is equals to this. So now you have to understand, it's a very simple coding system that you have to understand. Now let's solve this math and see the same thing we did. So is the V2, which is what? The read voltage. The V2, which is the read voltage. Now V2 is equals to what? 5 dots. Okay, let's say 5 over 20, 1023. This is what we just did here. 5 over let me bring it closer so that you can see it very clearly. V2, which is what? V2, which is equals to what? 5 over what? 1023 multiplied by what? 179. So okay, so which is what? The read voltage. Which is what? The read voltage. Which is the read voltage. So 179 is the read voltage. So let's take it that way, times the read voltage, RV read voltage, 179 volts. So now, okay, so we go. So this is V2 equals to what? 5 over 1023, which our scale value, in bracket times what? The read voltage. So let's put it that way. Let's go that way. In this place we introduce what? Okay, let's first of all type our what? The float. This is supposed to go to float. We are going to use float on this. So float. Float, that is it. Okay, correct. So put int read voltage. Int RV. RV, I use capital letter R and V, and that is it. Correct. Read voltage. Okay, so that is it. We have adjusted our variables, and let's come to this place so that we can adjust before the serial monitor. So we can put this one. Let's put this one so that you see. Let's put both of them so that you see what I'm doing here. Okay, so you see, from this is where we started, and this is where we are going. So I want you to understand how I adjusted this, how I got to this place. Okay, now enter. Cool. So now we are going to do our calculation. So the calculation is what? V2 is equals to what? V2 is equals to, V2 is equals to bracket 5 dot. The reason why you use dot, use a decimal point, is for you to tell the Arduino, the IDE, that the 5 here is what? It's an integer. It's not what? It's not a float number, because it's an integer. It's not a float number. So you are using, sorry, that's 5 dots over is a float number, because if you don't do it that way, the Arduino will see it as a what, as an integer, and it will give you 0.000000 as your final result. You can't get that 0.77 or 0 point something or 1 point something. Yeah, actually, if your V2 is 1 point something volt, if your reach voltage is 1 point something volts, you can't get that point. You might get only 1. And if it is 0 point something, you might not get that 0 point something. You might get only 0.0000. So that is it. So the dots here shows that what this, because it's 5 over 1023, so it's a floating number, it's not an integer, it's not a whole number, it's not an integer. So that is it. So it's a floating number, so that is it. So it's say divided by number divided by 1023, 10 to 1023 dots, because 1023 dot bracket closes times multiply, you use the number asterisk, sorry, times what, times read what, voltage, times read voltage, which is what, which is 173 scale, which is RV. We use read voltage as what, which is our read voltage, which is 173, so which is what, read voltage. So read voltage RV. Okay, so we have done this calculation here, and remember, so V2, which is analog read pin, which is A5. So V2 now is what? Is what? Read voltage, which is RV, is what? V2. So that is our what? Our read voltage. Because at the end of the day, at the end of the day, V2 is equals to what? 0 points, which is what? Which is our read voltage. So V2 now, V2 voltage, V2 across the resistor. 100 ohms resistor is what, is the read voltage. So V2 becomes what, the read voltage, which is a floating what, number. So V2 becomes what, RV. So read voltage, RV, read voltage. So that is it. That is how we arrived at this, all these things on this program. So we are going to download it and open our serial monitor, then we'll see how are we making any mistake. Let's just cross check and see where we put our dots and the semicolons and semicolons and our dots and our comma. Places we need to put comma. All these things are the things that that is going to affect you. So okay, now let's print and see. I believe it's going to go now. Boom. So now that is it. So that is the end of the tray. So now we can now open our serial monitor and see. Okay, wow, what am I seeing here? So okay, good. I'm seeing 0.8 volts, 0.87 volts, which is the actual real voltage in the real world. So that is it. Now the Arduino, now the IDE can now give us what, the real actual voltage, not giving us now a scale value. You see how we converted the scale value? You see how we converted the scale value to the what, to the real voltage, the real world voltage, and we did it on paper, but we don't want to see it on paper. We want to see it on the screen. We want to see it on the screen of Arduino, just like you're seeing it now. So we have to do also the calculation inside the IDE, so that we can see it. We have to do the calculation inside the IDE. We did it on paper, and we saw it on paper. 0.7 volts, 0.87 volts. But the IDE is still giving us what, a scale value. So now we have to do the calculation inside the IDE, so that we can see the real voltage inside the IDE. So that is how it goes. So it's very simple. I don't know if people will have this mentality that Arduino programming, Arduino coding, IDE stuff, all the C stuffs is a very cumbersome something. No, it's very simple. Know your basics, your simple mathematics, and the finish. You might not even be very fast in typing, pushing in codes, but as far as you can recognize alphabets and you can push in something in the keyboard. You can be able to do it, no matter how long it takes you. At the end of the day, just get it right. That is it. It can take you 2 hours to get it right. It might take another person 10 minutes to get it right. By the time it takes you 2 hours to get it right, next other time it's not going to take you 2 hours. It might take you 1 hour. Next other time you do it, next other time it might going to take you 30 minutes. Next other time it might going to take you what? 10 minutes. So the person that takes 10 minutes to code has been coding since. So he has paid the price. So you too have to pay the price by coding, doing a lot of experiments, doing it and over again. Practice makes what? Perfect. So become so good with your keyboard and they become so fast. And before you know it, boom, you will become a programming guru. So that is it now. So you can see now in our scale value has already turned to our ring voltage. So we can now see how we got what? Our 0.87 watt volts. So in our next tutorial we are going to do what? I think I'm going to go into the serial monitor. You leave that one for me to decide. Based on this tutorial, we know the best tutorial to bring up, to call up again. So all these things, I'm taking it bit by bit so that anybody, I mean anybody, even if you have not heard of Arduino before for the first time, it will still flow. So that is the way I structure the tutorial. I know I'm taking time, but I'm doing it in such a way that anybody can fit in. So that is it. Anybody can fit in. So that's why it's taking time. I'm taking time to bring different scenarios. Even I have also brought a piston and ring scenario to explain Arduino. Continuous piston and ring process of to explain, so that maybe mechanical person among us will understand what we are saying about loop. So that is it. So that is the end of the drill, and see you next time in our next tutorial, on tutorial number 16. You leave that one for me to decide what I will bring in, but it has to do with about serious stuff, serial monitor and rest of that. Okay, so now you do yourself a favor, do me a favor and do yourself a favor by getting this most excellent, the most complete starter kit. Every tutorial I will always mention this. The light is flashing on it too much. Okay, it's better now. Okay, so do yourself a favor by getting this. It's going to help you and in this tutorial. So that is it. So if this video makes sense to you, like and share, subscribe so that others will benefit. Like and share, others will benefit. You subscribe so that we get subsequent informations of you get a notification whenever I post a new video. Subscribe in my YouTube, that is Mr. Great Tech, and also like my page, Mr. Great Tech Review, my Facebook page. Continue to like. Okay, that is it. Thank you. God bless you, and bye bye for now. I'm your one and only Mr. Great. God bless you.